is the NH3 group. So for example, let us consider aryl halide, that is chlorobenzene. It is treated with ammonia NH3. So then chlorine is replaced by NH2 group. So the obtained compound is benzene with NH2 plus. It is NH2 and H. So then this H combines with Cl. So then it gives HCl. So it is the C6H5NH2. It is the aniline. So replacement by the amine group, chlorobenzene converted into aniline. So third replacement reaction. So replacement by cyanide groups. So for example, let us consider KCN, potassium cyanide group. So then chlorobenzene C6H5Cl, it is treated with KCN. So then Cl, it is the Cl. Cl is replaced by Cn. Cl combines with chlorine. So then the obtained compound is benzene with Cn group. So then potassium combines with chlorine, it gives potassium chloride. So it is the molecular formula C6H5Cl. So it is the cyanobenzene. So replacement by cyanide group, chlorobenzene is converted into cyanobenzenes. So these are the nucleophilic substitution reactions. So then second chemical properties are the electrophilic substitution reactions. So generally electrophilic substitution reaction is caused to resonance effect, same as nucleophilic effect. So then first reaction is halogenation. So now aryl halide, for example chlorobenzene, it is treated with halogens like that Cl2. So then Cl2. So chlorobenzene, it is treated with chlorine in the presence of Lewis acids, that is anhydrous. What is anhydrous AlCl3 or FeCl3 or Fe. So then these chlorine is substituted ortho position as well as para position. Then two compounds are obtained. In this, one compound is major compound, another compound is a minor compound. So then the obtained compounds are, so it is the Cl with the ortho position of the chlorine. So second compound is Cl with the para position of the compound. So then it is the 1,2 dichlorobenzene. It is 1, 2, 3, 4. 1,4 dichlorobenzene. 1,2 dichlorobenzene. It is the minor product. So it is 1, 2, 3, 4. 1,4 dichlorobenzene. So 1, dichlorobenzene, it is the major product. Why? Because it is major product. So the ortho group is present para position in this compound. chlorine is present at the ortho position. So then in generally para position compound is the major compound comparatively ortho position of the compound. So then second electrophilic substitution reaction is nitration. So then nitration electrophilic substitution reaction undergoes in the presence of nitration mixture. So the nitration mixture is the concentrated HNO3 and concentrated sulfuric acid. So the mixture of concentrated nitric acid and sulfuric acid is known as nitration mixture. So then chlorobenzene C6H5Cl chlorobenzene, it is treated with nitration mixture. It is HNO3 in the presence of concentrated sulfuric acid H2SO4. So HNO3 also concentrated. So then now it is HNO3. It is simply represented with OH and NO2. So then this NO2 group is substituted in the place of ortho position as well as para positions. It is ortho and it is the para positions. Then two compounds is obtained. One is major compound, second one is minor compound. So then it is Cl, it is NO2 plus it is Cl, benzene with Cl, so then it is the NO2. So now it is 1-chloro-nitrobenzene, it is the 1-chloro-nitrobenzene, it is the 1, 2, 3, 4. So 1-chloro-4-nitrobenzene. So it is the minor compound, it is the major compound. Because NO2 group present at para position, the obtained compound is more comparatively ortho position of the compound. So it is the 1-chloro-nitrobenzene, it is the 1-chloro-nitrobenzene with para position and it is the ortho position. So then third electrophilic substitution reaction is sulfonation. It is the sulfonation. So sulfonation reaction undergoes in the presence of concentrated sulfuric acid H2SO4. Now chlorobenzene, it is the chlorobenzene plus H2SO4 on strong heating. So then it is simply considered as OH and HSO3. So now this HSO3 group is substituted at ortho position as well as para positions. This ortho position, it is the para positions. So then the obtained compounds is benzene with chlorine. So then it is the HSO3. So HSO3 group is present or substituted at ortho position, same as it is benzene with chlorine, and HSO3 group is substituted at para positions. So then it is first carbon, it is second carbon, 2-chloro benzene sulfonic acid, benzene sulfonic acid, benzene sulfonic acid. So there is the first carbon, it is second carbon, third carbon, it is the fourth carbon, it is the second carbon. 4-chloro benzene sulfonic acid. So 4-chloro-benzosulfonic acid, HSO3 group is present at para position. The the obtained compound is the major compound. In this compound, HSO3 group is substituted at ortho position. It is the minor compound. So it is the sulfonation reaction. So then fourth one is Friedel-Crafts reactions. In Friedel-Crafts reactions, first one is Friedel-Crafts alkylation. Friedel-Crafts alkylation. So in Friedel-Crafts alkylation, chlorobenzene, so then chlorobenzene, it is C6H5Cl. It is treated with alkyl halide. For example, let us consider CH3Cl. So then, in the presence of anhydrous AlCl3, now CH3 group is substituted at ortho position as well as para positions. So then the obtained two compounds are, so it is the chlorine with the CH3 group plus chlorine with benzene, and it is the CH3 group. So in first compound, in this compound, methyl group is substituted at ortho position, methyl group is substituted at para position. So then it is the 1-chlorotoluene, it is the 1, 2, 3, 4 chlorotoluenes is obtained. So then it is the minor compound, it is the major component. So it is the Friedel-Crafts alkylation. So then second reaction is Friedel-Crafts acylation. So generally Friedel-Crafts acylation reactions undergoes in the presence of acetyl halides. So then B is Friedel-Crafts acylation. Friedel-Crafts acylation. Generally, these reactions are undergoes in the presence of acetyl halides. So, for example, let us consider chlorobenzene C6H5Cl plus it is CH3COO, it is Cl. CH3 acetyl chloride CH3COCl. So then in this COCH3 group is substituted at ortho position as well as para positions. The obtained compounds is, so then benzene with chlorine and COCH3 group is substituted at ortho position, and the second major compound is, it is the benzene with chlorine, and COCH3 group is substituted at the para position. So then it is the 1, it is 2, so then 2-chloroacetophenone, it is the 2-chloroacetophenone, it is 1, 2, 3, 4, it is 4-chloroacetophenone. So 4-chloroacetophenone is the major compound and 1-chloroacetophenone is the minor compound. So these are the electrophilic substitution reactions. So then final reaction is aryl halides react with metals. So the best metal is sodium. The reaction undergoes in the presence of dry ether. So first reaction is Wurtz-Fitting reaction. So in Wurtz-Fitting reactions, both aryl halides and alkyl halides are involved in these reactions. For example, let us consider chlorobenzene. It is the aryl halide. For example, if you take CH3Cl, it is the alkyl benzene. So then CH3 group is the addition with in the presence of Cl. So then it is CH3 Cl benzene. So benzene, it is the benzene with CH3 group, and it is Cl2. Cl2. So then it is C6H5 CH3 toluenes is obtained. Benzene with methyl group is toluene. So second reaction is, for example, this reaction consider as, for example, if you take what is 2 moles of the 2 moles of the aryl halides. So then it is the Na 2 moles of the C2H5Cl, plus it is treated with 2 moles of sodium in the presence of dry ether. So then simply this chlorine is combines with sodium, it uses 2 moles of NaCl, then the obtained compound is biphenyls. The biphenyls are obtained. These two are combined with this one, and it means it is C6H5, it is C6H5. The obtained compounds are biphenyls. And Wurtz fitting reaction also consider as, generally it is the aryl halide C6H5Cl plus CH3Cl. The reaction undergoes in the presence of sodium also. So generally 2 moles of sodium and 2NaCl, the obtained compound is benzene with CH3. So these are the Wurtz fitting reaction, and it is simply fitting reaction. In fitting reactions, biphenyls is obtained. So then after completion of the chemical properties of aryl halides, generally ethyl chloride C2H5 are used as a solvent. It is used as a local anesthetic, and it is also used as a refrigerant. So see, ethyl chloride used as a solvent, local anesthetic, and a refrigerant. And also by the using of ethyl chloride to prepare the Grignard reagent, what is RMGX. So simply aryl halides, for example C6H5Cl, are used in the manufacture of aniline. What is aniline? Same as biphenyls, same as DDT, and also polyhalogen compounds, for example CH3Cl chloroform. So these are all the applications or uses of the ethyl chloride and what is aryl halides.